This is SpaceTime, Series 24, Episode 21, coming up on SpaceTime. Determining how super-Earths and mini-Neptunes are made. How far are we from nuclear-powered space transport? And the Russian spaceship out of control. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have now found over 4,000 exoplanets, that is, planets orbiting stars other than the Sun. And the most common type of exoplanets are the so-called super-Earths and mini-Neptunes, planets up to 4 times the size of Earth. And that's really interesting because there are no such planets orbiting in our solar system. So, understanding how super-Earths and mini-Neptunes are made will tell astronomers not just a lot about them, but also about what our own solar system's lacking. Until now, super-Earths were thought to simply be the rocky cores of mini-Neptunes that have lost their extended gaseous atmospheres. But new research reported in the Astrophysical Journal suggests that at least some of these exoplanets never had gaseous atmospheres to begin with. Observations suggest that between 30 and 50% of all stars have either super-Earths or mini-Neptune exoplanets, and that the two populations appear in roughly equal numbers. So, where did they come from? One theory is that most are born as mini-Neptunes, but some are then stripped of their gaseous envelopes by stellar winds and radiation from their host stars, leaving behind only a dense rocky core. This same theory, however, also predicts that the Milky Way would have very few Earth-sized and smaller exoplanets, known as Earths and mini-Earths. And the problem is, observations show this doesn't appear to be the case. So, astronomers use computer simulations to track the evolution of these mysterious exoplanets. The model uses thermodynamic calculations based on how massive the rocky cores are, how far away they are from their host stars, and how hot the surrounding gas is. One of the study's authors, Assistant Professor Eve Lee from McGill University, says contrary to previous theories, this new model shows that some exoplanets simply are not able to build gaseous envelopes to begin with. That means that not all super-Earths can be the remains of mini-Neptunes. Some of them really are simply big terrestrial rocky planets. Lee says planetesimals larger than, say, moon size usually have enough gravitational pull to attract surrounding gas to form an envelope around the core. Over time, this envelope of gas cools down and shrinks, creating space for more surrounding gas to be pulled in, causing the exoplanet to grow. And this same process keeps on going until the entire gaseous envelope cools down to the same temperature as the surrounding nebula gas. At that point, the envelope can no longer shrink, and so growth stops. But for smaller cores, this envelope's tiny, and so they remain rocky planets. Lee says the distinction between super-Earths and mini-Neptunes comes about from the ability of these rocky planets to grow and retain gaseous envelopes. She says the new model could eventually also help decipher how common rocky exoplanets like the Earth and mini-Earths could be. This is SpaceTime. Still to come, how far are we from nuclear-powered space transport? And a Russian spaceship out of control. All that and more still to come on SpaceTime. A new report by America's National Academies of Sciences, Engineering and Medicine think tank warns that NASA will need to pursue an aggressive and urgent nuclear technology development program in order to properly support a human mission to Mars in 2039. The study says NASA should commit within a year to conducting an extensive assessment of the merits and challenges of using different types of space nuclear propulsion systems. And it says the agency needs to make firm commitments before the end of this decade. Back in the 1950s and 60s, a company called General Atomics developed Project Orion, a proposal for a nuclear-powered rocket propelled by the detonation of small nuclear bombs against a large steel pusher plate attached to the spacecraft by shock absorbers. Now, that all might sound pretty outlandish to you and me today, but back then it was seriously considered as a potential real thing. The spacecraft would need to be built like a submarine, have a mass of several thousand tons, and it would require a crew of more than 200 people. But if built, it could travel from Earth to Mars and back again in just a month. And that compares to at least 12 months for a round trip using today's very best chemical rocket engines. The same craft could also visit Saturn's moons in a 7-month mission, compared to today's chemically powered missions of around 9 years. Engineering problems such as radiation shielding for the crew and pusher plate lifetime were resolved. And while the system appeared to be entirely workable, it was eventually shut down in 1965 following the introduction of the Nuclear Partial Test Ban Treaty between the United States and Soviet Union. Okay, let's move on half a century and a bit more, and a manned mission to Mars with today's chemical rocket engine technology will take around a year. That's as long as you don't hang around on the red planet for more than a few days. Stay any longer and you'll miss your tight return window. And thanks to the different orbits of Mars and Earth, that means your round trip will blow out to around 2.5 years, which is currently what's planned for any manned mission to Mars. So, the idea of a much faster journey to Mars using nuclear power is getting a serious revisit, but with a modern twist. The new technology will focus on either nuclear electric propulsion or nuclear thermal propulsion systems for human missions to Mars. Both systems are similar. Nuclear electric propulsion converts thermal energy from a nuclear reactor into electrical energy to power electric thrusters, while nuclear thermal propulsion uses thermal energy from a nuclear reactor to heat a rocket propellant in order to create thrust. For nuclear electric propulsion to work, you need to scale up the operating power by orders of magnitude for each subsystem. Then there's the need to still have scaled-up chemical thrusters for departing Earth's orbit and for entering and departing Mars orbit. On the other hand, nuclear thermal production would need to heat up its hydrogen propellant to around 3,000 degrees Celsius. And you'd still need to be able to store enough of that hydrogen in liquid form for the journey and to safely capture the exhaust during ground testing. But the important thing is, none of these issues are technically impossible with today's knowledge. And the benefits of nuclear propulsion systems have the potential to substantially reduce journey times, making manned missions to Mars more viable. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
They now want to get to Mars faster. Now, it is depending on when you go and how you fuel it up. It's a long journey. It is a very, very long journey, sometimes longer than it should be, I suppose, but you've got to allow for so many factors when you're traveling across the expanse of space or just going to the next door neighbour's place, as is the case with Mars. But they're wanting to get there faster, which makes perfect sense. And the answer might be nuclear rockets.
Yeah, that's right.
I like this idea, I really do like this idea.
Yeah. It's not a new one either. It goes back to the 60s, the earliest days of rocket flight. People were talking about using nuclear rockets to whiz around space. In fact, we were thinking of doing everything by nuclear power in those days. But just talking about Mars, the standard journey time for Mars, as we've seen, that's a 7-month trip. And that's actually about as quickly as you can do it with normal chemical rockets, because what you're doing is you're looking for the lowest energy transfer between the orbit of the Earth and the orbit of Mars. And that is something called a Hohmann transfer orbit. Hohmann, if I remember rightly, is his name. I checked up the guy a while ago. He was an engineer, but he was thinking the 50s proposed the way to get from one planet to another was to essentially put your spacecraft into an orbit around the Sun, which is elliptical, basically a stretched orbit, not circular, but one that's quite elongated. And you put your spacecraft into that orbit, it heads halfway round one orbit, and then you basically fire your braking rocket so that it goes into orbit around the other body, which is Mars. And that's the thing that gives us the standard 7-month or so travel time, 7 to 8 months. Sometimes 9 months, depends on the exact orientation of Mars and the Earth. But the other point about that is you can only do it every 2 years, which is why we had this rush of spacecraft being launched last July. Because if you miss your window, you send your rocket off in its transfer orbit, and when it gets to the orbit of Mars, Mars is already somewhere else. It's moved along. So the timing has got to be perfect, and that is why you've got this 2-year window. It would be very good to be able to change all that. And that's why people are once again starting to look at nuclear rockets. There have been many nuclear rockets tested, in fact, never, I think, going into space, but certainly tested on the ground, dating through the late 1960s. Plenty about this stuff on the web. But the program kind of in the post-Apollo era, was shut down. In fact, in 1973, in the United States, I know nuclear rocket technology has been tested in Russia, we know that, but not in the United States. It was shut down in 1973 with the dawn of the Space Shuttle program, when the idea of going to Mars was shelved because the US wanted to build a space station and wanted to have a reusable spacecraft, the Space Shuttle, which then basically took over. Well, let me just take a pause there. Nuclear rocket research stopped in 1973, but nuclear research didn't. And we now know much more about nuclear technology than we did back in the 1960s. And in fact, there is a difference in the kind of fuel that you might use. It was always highly enriched uranium that was proposed back in the 60s, which is kind of the stuff that you make nuclear weapons out of. It's not very nice. But there is something... Yeah, good stuff, yeah. There is low enriched uranium, which might now open the way because the technology has moved on. Basically, what you're trying to do, just let me explain how a nuclear rocket works. You get your radioisotope.
Aside from going kaboom.
Yeah, kaboom. Yeah, it shouldn't do that. It's gone wrong if it does that. You're in bad shape. It's basically a pellet of uranium that is undergoing fission, which is the process that breaks up the atoms and releases heat. The amount of heat that is released is enormous. And what you do is heat up a gas, it's usually hydrogen, up to about 2,500 degrees Celsius. And then you blow that out through a venturi at the back, which gives it a very high velocity. And the key point about that is you end up with 2 to 3 times the efficiency, the propulsion efficiency of a chemical rocket, one that uses liquid fuels, the standard thing. So you've got this sudden increase in efficiency by a factor of 2. And that means, for the same size of rocket, you get 2 or 3 times more power and more of the oomph. So there is a proposal now. It's actually mandated by the US Congress, which approved $125 million for this project on the 22nd of May 2 years ago, 2019, to look at the development of nuclear thermal propulsion. NASA is the agency that's looking after this. The approval, quoting here, calls upon NASA to develop a multi-year plan that enables a nuclear thermal propulsion demonstration, including the timeline associated with the space demonstration and a description of future missions and propulsion and power systems enabled by this capability. It's a really broad remit. It's, it's saying, okay, we'll give you nuclear toys to play with. What can you do with them? So, yeah, very interesting prospect.
Okay, they're more powerful, therefore faster. So how much quicker would the trip to Mars be with a nuclear-powered rocket?
Well, even just the standard thing that we've been talking about, using nuclear fission, using uranium as a fuel, the prospect would bring the transfer time down to 100 days, which is kind of 3 months-ish. So you're cutting it by more than a factor of 2. Just because you can actually boost the spacecraft to a higher velocity, that puts it into a more tightly elongated orbit, and you get there quicker. There is another advantage. Actually, there are a number of advantages. One is that the lower travel time means that you don't need the same amount of supplies, the resources that the astronauts themselves use during the flight. And paradoxically, even though you're being driven by a nuclear rocket, you've got a lower radiation dose from the solar radiation on the astronauts as they fly to the moon. So it's kind of got advantages on both sides. And a third one, which I think is in some ways, the clincher is this. It means that you're not limited so strictly to this 2-year window. You could take yourself off to Mars over a wider window of opportunity, if I can put it that way, because you've got the possibility of additional thrust that you could actually choose your time, departure time, probably not completely freely. You probably still have windows, but they would be much wider windows than they are now. You don't have to rely on the 2 planets being exactly aligned.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, a Russian spaceship out of control as it nears the International Space Station, and SpaceX loses a Falcon 9 booster at sea. All that and more still to come on Space Time. Russian cosmonauts have been forced to take over control and manually guide a Progress cargo ship into a docking port aboard the International Space Station after the Progress's automated docking system suddenly failed. The Progress MS-16 cargo ship was on final approach, just 20 metres from the Piers docking port, when its radar-guided Ker's automated rendezvous system suddenly crashed. That forced cosmonauts to quickly activate the Taru manual flight control system inside the Zvezda module to take over and remotely control the Progress for the final stage of the docking manoeuvre. The cargo ship had launched 2 days earlier aboard a Soyuz 21A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
We have engine start and the second umbilical tower separation, turbopumps at flight speed, and liftoff of the 77th Progress resupply vehicle for its 2-day, 33-orbit journey to the International Space Station. The flight continues nominal so far, first stage. Structural parameters are nominal. Soyuz 2.1A booster, its first stage engines continuing to fire. Vehicle is reported stable, and that first stage continuing until about 1 minute and 58 seconds after launch. Now 1 minute into the flight of Progress 77, parameters being reported as nominal. At liftoff, the International Space Station was flying 260 statute miles over southern Argentina, and we've had first stage shutdown and separation. Strap-on solid rocket boosters have been jettisoned. The spacecraft now traveling at 4,500 miles per hour in velocity, 29 miles in altitude, and 29 miles downrange from the Cosmodrome. Continuing to hear nominal calls.
The mission marks the 77th launch of a Progress supply ship to the International Space Station. The previous Progress cargo ship, the Progress MS-15, undocked from the space station a few days earlier and, loaded with trash and disused equipment, was sent on a fiery suicidal death plunge, burning up in the atmosphere over the southeastern Pacific Ocean, an internationally designated satellite graveyard. The Progress 16 is carrying some 2,460 kilograms of fresh water, fuel and supplies. This includes 600 kilograms of propellant, which was piped into the space station's Zvezda service module propulsion system, together with 420 kilograms of fresh water and 40.5 kilograms of pressurized gases to supplement the space station's breathable atmosphere. Also aboard the Progress were some 1,400 kilograms of food and general supplies, including biomedical experiments to study obtaining food and oxygen from algae in microgravity, and equipment to help cosmonauts detect and patch leaks on the space station following a spate of incidents on the Russian modules of the orbiting outpost. The supply ship will remain docked to the space station until July, when it will depart with the Piers docking port still attached. The long-awaited removal of the Piers module, which has served as a docking port and airlock for spacewalks on the space station since 2001, will make room for the arrival of the long-awaited Nakua Science Laboratory module later this year. A similar module to Piers, named Poisk, will remain attached to the space station. Nakua will be the largest addition to the Russian segment of the space station since the year 2000. That's when Zvezda itself was launched. It'll be flown up aboard a Proton heavy-lift rocket. The Progress MS-16 will guide itself along with its disused Piers module back into the atmosphere, where the pair will burn up at the end of the mission. Interestingly, Nakua was originally built back in 1995 as a ground backup for the Zarya module. It was converted to a flight-capable module in 2004 as a cost-saving measure for the Russian Federal Space Agency Roscosmos. It was originally slated to launch in 2007, but has been repeatedly delayed by a seemingly never-ending string of technical issues, including faulty fuel valves in the propulsion system. That required extensive cleaning and replacing most of the plumbing. But then the entire propulsion system needed to be replaced anyway after surpassing its use-by date. Next, metallic dust contamination was found in the fuel tanks. That resulted in more cleaning and refurbishment. However, those repairs weren't successful, resulting in the decision to build completely new replacement tanks instead, and further pushing back the launch date. When it does finally fly, the 30-metre-long Nakua will be Russia's primary space science research laboratory. It'll be used for experiments as well as docking and cargo. The 2,300-kilogram module will also serve as a crew work and rest area. Roscosmos has also announced plans to launch a new connecting node called the Prakal Nodal Module in September. The ball-shaped Prakal will be docked to Nakua and have 6 docking ports, an active port attached to Nakua, and 5 passive docking ports for future Soyuz and Progress spacecraft. This is SpaceTime. Still to come, a Falcon 9 rocket lost at sea, and later in the science report, at least half of all COVID-19 infections found to come from people who aren't showing any symptoms. All that and much more still to come on SpaceTime. SpaceX has lost a Falcon 9 booster during a landing attempt following what was otherwise another successful launch carrying 60 more Starlink satellites into orbit. The mission from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida had been delayed by a day due to bad weather. On returning to Earth, the rocket's first stage booster, which was on its sixth mission, failed to land on the drone ship Of Course I Still Love You and apparently splashed into the North Atlantic Ocean. This was the 19th Starlink mission, bringing the total number of Starlink broadband internet satellites now in orbit to well over 1,000, much to the disappointment of scientists and astronomers everywhere. Worse still, another 11,000 Starlinks are planned for launch, and that could eventually reach some 42,000. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has concluded that at least half of all COVID-19 infections come from people who aren't showing any symptoms. A report in the Journal of Proceedings of the National Academy of Sciences has found that during the initial wave of the COVID-19 outbreak in New York City, only 1 in 5 to 1 in 7 cases of the virus was symptomatic. Researchers found that non-symptomatic cases, that is, people showing no symptoms, substantially contribute to community transmission, making up at least 50% of all SARS-CoV-2 infections. Some 2.5 million people have now died from COVID-19, and another 111 million have been infected since the virus first emerged from Wuhan, China. There's new evidence that air pollution can make you go blind. A report in the British Journal of Ophthalmology has confirmed a link between air pollution and an increased risk of progressive and irreversible age-related macular degeneration. A study of over 100,000 people found that those exposed to higher fine particle air pollution had a higher risk of age-related macular degeneration, while all other pollutants, except coarse particulate matter, were also associated with changes in retinal structure. Age-related macular degeneration is now the leading cause of severe vision impairment in people aged over 40. For centuries, humans have blamed the moon on their moods, on accidents, even on natural disasters. But new research indicates that our planet's celestial companion impacts something else entirely: sleep. A report in the journal Science Advances has found that people's sleep cycles oscillated during the 29.5-day lunar cycle. It seems in the days leading up to a full moon, people tend to go to sleep later in the evening and they sleep for shorter periods of time. Scientists found the oscillations occurred regardless of access to electricity, though variations are less pronounced in individuals living in urban environments. Researchers used wrist monitors to track the sleep patterns of 98 people in 3 different communities in Argentina. Participants in all 3 communities showed the same sleep oscillations as the moon progressed through its 29.5-day cycle. Depending on the community, the total amount of sleep varied across the lunar cycle by an average of 46 to 58 minutes, and bedtime seesawed by around 30 minutes. On average, people had the latest bedtimes and the shortest amount of sleep in the night's 3 to 5 days leading up to the full moon. A new study claims first impressions really are an accurate way to assess someone's personality. The findings by scientists from McGill University are based on a study of 372 people taking part in a series of speed dating events in Montreal, Canada. Participants were asked to complete a questionnaire assessing their personality and well-being. Meanwhile, a close acquaintance would also fill out the same questionnaire on the participant's personality. Participants were then given a series of brief 3-minute first date encounters and asked to rate each of them. And it turns out that on average, people were fairly accurate in their assessment of their dates' personalities. Australian skeptics have raised concerns about a new study by Durham University, which claims that spiritualist mediums might be more prone to what they call immersive mental activities and unusual auditory experiences in early life. You and I might call that hearing voices that aren't really there. The study contends that this might explain why some people and not others eventually adopt spiritualist beliefs and engage in the practice of hearing the dead. Tim Mendham from Australian Skeptics says the problem is that the study almost implies it's a cause and effect, and it fails to doubt the underlying practice of spiritualism and hearing voices. Mendham says it might just be that people who are inclined towards spiritualist practices also suffer from and are prone to hearing voices, rather than one leading to the other.
Study led by Durham University in the UK, which was looking at spiritualist mediums, the sort of people who talk to the dead, seances, that sort of thing. They're all around, they're all the rage. You see them performing everywhere. And this study was suggesting that they looked at a whole range of, I think, 65 clairaudient spiritualist mediums. Was that media? Never quite sure. Anyway, 65 people who hear voices from the Spiritualist National Union in the UK and a number of members of the public as well, to sort of balance it out. And they said that the spiritualists in their youth heard voices, and the suggestion is that's why they become spiritualists. So my concern is that that's a cause and effect assumption. Now, this report doesn't seem to doubt about voices, really. There's no great indication that it's saying this is rubbish. There's nothing there to hear or see. But it's saying that because these spiritualists have heard these voices in their younger years, they might be more prone to picking up these things. But the question is that someone who believes they're a spiritualist probably also believes they hear voices. There's no guarantee that either one is true or that there's an association between either one, apart from in the mind of the spiritualists. No one else hears the voices, of course, it's just the spiritualists themselves. And the fact that this study is more a social study, or should be a psychology study rather than a physical or physics or even a medical study, because you should be looking at people's beliefs, not actual things that happen, because you can't prove the actual things that happen anyway in this particular case. And the suggestion of an association, voices in the youth make you a spiritualist now, is faulty logic.
I think what we're dealing with here is actually a psychiatric problem.
Yeah, quite possibly. But I think from that point of view, it should be a psychiatric study.
Exactly.
Rather than this was an interdisciplinary study of voice hearing. I don't know what they were trying to find out. I don't know how serious they are about believing that these things are real, but certainly the association that they are making in this study is, to me, tenuous, or at least based on a false assumption.
Well, it came out over the holiday period, and often you'll find studies coming out during that time period which are simply there to promote the promoters.
But there's a lot of studies out there that are sort of dodgy, right?
Yeah.
But the fact it was published on the American Association for the Advancement of Science website is a bit concerned about their discernment as well, or whether they're just publishing stuff for clickbait. And certainly it has achieved some sort of notoriety because it's an interesting topic.
We're talking about it.
We're talking about it. It's all our fault, mate. Yeah.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.